The Dynamic Learning Maps Alternate Assessment System is a new assessment designed to more validly measure what students with significant cognitive disabilities know and can do. This presentation on calculating accurately with division will provide information to teachers of students with significant cognitive disabilities who will complete the alternate assessment. This training is one in a series of training videos that supports teachers in their efforts to teach and assess. Sponsored by a grant from the U.S. Department of Education, Office of Special Education Programs, this training is part of the professional development efforts of the Dynamic Learning Maps Alternate Assessment Consortium. In the series of modules on calculating accurately with addition, subtraction, multiplication, and now division, we want to be sure that teachers are understanding the big idea that mathematics is an integrated whole, rather than a compilation of unrelated topics. Counting and composing and decomposing numbers helps students learn to add and subtract. Addition and subtraction help students learn to multiply and divide. But we have to help students make these cognitive connections. Most students with significant cognitive disabilities do not know that they can use their prior knowledge to help them learn something new. Take, for instance, students' initial experience with division. They often involve sharing objects equally and using their counting skills to help support division skills. For example, students might be asked to show how 3 children could share 12 boxes of crayons fairly. Using 12 boxes, students might divide the counters into 3 groups while counting out 1, 2, 3, 1, 2, 3, until all the boxes had been distributed, then counting and reporting that each child would have 4 boxes. Here's another example of how students can use what they know and apply it to division. Consider the following problem. Andrew has 28 dog treats. If he gives Cammie 4 dog treats each day, how many days will Cammie get treats? The division problem is 28 divided by 4 equals what? Students can use what they know about addition to solve this problem. They can use representations to help them keep track of the number of repeated additions they make and repeatedly add 4 until they get to 28. 4 and 4 more is 8. 8 and 4 more is 12. 12 and 4 more is 16, and so on. Then students will count the number of times they added 4. So Cammie will have 7 days of treats. This example shows how students can use subtraction to help them understand division. Using the same problem, Andrew has 28 dog treats. If he gives Cammie 4 dog treats each day, how many days will Cammie get treats? Students could start with 28 bones and remove them in groups of 4, making the connection to repeated subtraction, then counting the number of times 4 was subtracted. Finally, let's see how multiplication and division work together to solve this same problem. We know from the problem that there are 28 bones altogether, and that Cammie will get 4 bones each day. So the equation would be 28 divided by 4 equals what? Using what they know about multiplication, students could say 4 times what equals 28? 4 times 7 equals 28. They can apply this knowledge to the division problem. 28 divided by 4 equals 7. Cammie will get treats for 7 days. These examples of using knowledge of other operations to support new understandings of division are an important concepts for students to gain. If they memorize facts and forget them, there's no strategy for figuring it out. But if they understand multiple ways to solve an equation, then they are not stuck when their memory of the fact fails. Pause for Activity 1. Next, let's focus our attention on the connection between learning division and learning language. What if your student's biggest challenge in learning division is that they cannot understand the words that you are using to convey the mathematical concepts? In part, this may be because we tend to describe the process of division rather than the ideas of division. Here's an example of describing process. 10 divided by 3 means divide 10 and 3 to get 3. Place this on top of the 0 and the division sign. Multiply 3 by 3 to get 9. Place this under the 10. Subtract 9 from 10 to get 1. This is the remainder. Now listen to the difference when we describe the idea of division. We are going to divide 10 items fairly between two of you. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's share them fairly. A fair share means the same amount for each person. 1 for you and 1 for you. It's fair. 2 for you and 2 for you. It's fair. 3 for you and 3 for you. 4 for you and 4 for you. 5 for you and 5 for you. How many items did you each get? Count the items for each student, touching each treasure as you count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Wow, we had 10 items. When we shared them between two people, they each got 5. We divided them fairly. 10 divided by 2 equals 5. When you share fairly a group of items, you divide it into smaller groups. A fair share means an equal amount for each person. When we teach division or any other math concept, our instruction and activities need to help develop and expand the student's receptive and expressive language. We want them to hear, and for AAC users, see good language models. We can provide multiple opportunities for students to make meaning of mathematical vocabulary through pictures, words, and symbols. For example, here's a word problem that focuses on the word divide. Divide a package of 8 candy bars between 4 people. 8 divided by 4 equals what? How many candy bars should each person get? The following is an example of the Anchor, Think and Do, Apply lesson format that we might use to teach the word divide. The anchor part of a lesson should activate or build new background knowledge, establish the purpose for the lesson, and provide the teacher time to teach and model the learning concept. For a lesson that focuses on teaching the word divide, begin by talking to students about what things they share with someone else, at home or at school, and relate that idea to dividing things fairly. Provide multiple opportunities for students to experience division problems and show the students what to divide. Use the words divide and share fairly over and over again, always relating the words used back to the physical items, in this case, the candy bars. Talk about and model dividing the candy bars between 4 students. At the end of the conversation, we will use the words of the problem and restate it, providing the solution. We are teaching them what the words of the problem mean with respect to how the candy bars must be manipulated and what must be divided. The next part of the lesson Give students the opportunity to think about and do a similar problem without teacher instruction. The purpose is to have students think for themselves and for teachers to observe what the student actually does with the information. This will help us be able to provide informative feedback and correct misunderstandings in the next phase of the lesson. In the apply part of the lesson, students communicate what they did. This can be through showing and/or telling. And then we will provide informative feedback. Many students, including students with significant cognitive disabilities, may get a right answer, but really have no idea why or how they got it. So the other thing we will do is make explicit what the student did to get the answer by helping them recreate it or helping them describe what they did. And since our example lesson is on understanding the word divide, we might say something like, "You started the problem by counting how many candy bars there were altogether. You had 8. Then the problem said to divide the candy bars between 4 people, so you had 4 groups. You gave each person 1 candy bar and then gave each person 1 more candy bar until all 8 candy bars were shared equally in the groups. Then you counted how many candy bars were in each group. There are 2 candy bars in each group. So 8 candy bars divided by 4 people means each person will get 2 candy bars." The main idea of this section of the presentation is that we need to build students' receptive and expressive language in mathematics. For students who use augmentative and alternative communication, they should have access to the symbols for all of the operations, including division, on a communication board with the number sequence, as well as access to their core vocabulary. However, these symbols do not carry meaning until we teach students the word receptively and pair it with the symbol. But it is also important to remember that just having access to these symbols does not ensure understanding of them. We should create lessons that explicitly teach the meaning of the words and allow students multiple opportunities to figure out and demonstrate the meaning. Pause for Activity 2. So far in the presentation, we have been referring to division in a sharing situation. But there are actually 2 types of division problems we need to plan for and help our students think about: the sharing problem and the grouping problem. In the sharing problem, we know the total number of objects, and we know how many groups there are. What we don't know is how many are in each group. An example of this type of problem would be 3 children want to share 12 boxes of crayons fairly. How many boxes would each child get? The next type is grouping problems. In this type of problem, students know the number of objects in a group and the number of objects altogether. But what they have to figure out is how many groups can be made based on those amounts. The earlier problem, Andrew has 28 dog treats. If he gives Cammie 4 dog treats each day, how many days will Cammie get treats? Is a good example of a grouping problem. One thing we need to remember is that it is not necessary to teach students to distinguish between these problem types or to learn to label them, but to provide many experiences with both types. Thank you for participating in today's module. For more information, please go to www.dynamiclearningmaps.org.